Hi guys, let's solve today's LeetCode problem. What do we have today? Let's see. Medium one, sort colors. Given an array nums with n objects colored red, okay, white or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. We will use the integers 0, 1 and 2 to represent the color red, white and blue respectively. You must solve this problem without using the library's sort function. Well, output. Okay. Sounds like we just need to calculate the count of every color and then create an array. I can do it with two loops. I don't want to use regular sorting, of course, because its complexity is O log n log n. We can use linear complexity here. In place. We should sort them in place. So without extra space. Okay, got it. What can we do here is just go through the array and like replace numbers or switch numbers when we see them. So let's create a loop. For let I would be equal to 1. I will start from the first one, not from 0 index, because we need previous number as a reference. Maybe. But let's see. I less than nums length, and we will increment I here. What do we need after that? How can we solve this problem? We see 0. We can how to say, swap. We can swap 0 and 2 instantly. After that, something strange. I cannot select text. Now it's okay. Well, after that we can swap 0 and 2. Then we have 2 and 2. Then we have 1 and I know that we should swap this number with this, and then this number with this. Yep. Well, it's interesting, but we only have three colors, which means that we can just put two numbers twos and threes. We can put zeros to left side, and we can put twos to right side, and one would be remained in the center. So how to do that? If we see 2, we swap it with 0, and we will get something like this. Then we can move forward and see that here is 0. We can say that it should be here. Then we see 2 and swap it with the last index that was not replaced by 2, and here we will have 2 and 1. Okay, and we will do it until we go to the center. So we need 2 indexes here, and every time we need to find last 0 index would be equal to -1, and last 2 index would be equal to numbers length. And while true, we will be doing as follows. We need to increment last 0 index. Or we will increment it until it would not be 0. Yep. So while true, last 0 index increment, and if the numbers at last 0 index is not 0, then we will break it. Now we know that the number at this index is not 0. Or we can start from 0 and say while this condition is met, we will increment it. Then I would name it first to index. Or not. First to index from end. It would be like first last to index. I would name it last to index, okay. And here we will start from numbers -1, and while last to index is not equal to 2, we will decrement it. Now we know that we have two numbers here, and we should put it somewhere. The problem is that it can be number 1. What can we have here? There could be 3 combinations. It can be 1 and 1, it can be 2 and 1, and it can be 1 and 2 as well. No, we don't. 2 and 1 and 1 and 0. So if we will have this combination, we just need to swap it and move to the next step. Then last to index would be decremented. If we have this, it will be done as well. We will swap it and everything would be okay. But if we are having this combination 1 and 1, what can we do here? Let's try to imagine what we can do here. We should try to look look for zeros and twos in the center. We cannot just remain ones on the place. So if numbers their index equals to 1 and this one equals to 1 as well, then we need to do something. In other case, we just need to swap them. As I remember, we can do it like this. Let me check. X equals to 1, 2, x at index 0, x at index 1 equals to x at index 1, x at index 0, x. Yes, it works. So in this case, we just swap it. In other case, what I would do, I need to find something different from 1 in between of these indexes. If we have something in between, and if we have 0, for example, we should swap it with the first one. If we find 2, then we should swap it with last 2. And what will we do next? Actually nothing. We can then move forward. So what will we do here? Last 0 index, last 1 index. What will we do here in between of 1 and 1? Is that we need to go further and swap these numbers. But can we apply this algorithm to the whole algorithm and remove these steps? So we're starting from this state and then we're moving forward. We see 2 here, we move it to the right. Yeah, sounds pretty reasonable. But for once, it's a little bit different. But we still have to keep last 0 index. But when we encounter first one, we should start another algorithm then. Yes, sounds like that. Okay. First one index would be equal to 0 index, and last one index would be equal to last to index. Then while true, we would do the same with one indexes. If it's not equal to 1 and is not equal to 2, if last to index, yep, if it's not equal to 1 we will increment it, if it's not equal to 2 we will increment it. And if first one index equals to last one index, we will return it the value. And here's the same. If last 0 index would be equal to last 2 index, we will return the value. But if they are not equal and we found something, then we should swap it. If number numbers at first one index equals to 0, then we should swap it with the last 0 index. But it's not last 0 index, it's last non-zero index. Okay, I see that my algorithm looks complicated. Let's look at that from the side and think about what we can do in another way. We can still use indexes. We can still pivot, swap numbers. And I even understand what we should do, but how to do it, I don't really understand. We need to filling it from moving from two different sides. If we see something different than 0 from left, or something different than 2 from right, and we cannot just swap it, so we see once. Okay, what we can do is that moving from left, we just looking for 2s, and when we're moving from left to right, we're just putting number 2 to the end of the array. We're just swapping actually okay, we can decompose this task into two other tasks. The first task is to put all the 2s to the end of the array. And at the same time, we can, yes, let's just solve this task from the beginning. For let or while true, last to non to index from the end. Let's say it would be numbers length. First thing that we should find is that we should find non to index from the end. How can we do it? Pretty easy. Length -1 while numbers non to index from the end is not equal to 2, we will decrement this index. If it is equal to 2, we will decrement this index. So if it is equal to 2, it will still the same. If we have okay, we found first non to index. After that, we will do next thing. We will say that let start index would be equal to 0, then we will look from the non to index, and if none to index from the end less or equal to start index, we will break this loop. And on every iteration we would do this thing. If numbers at, I would name it left index, not start one, at left index would be equal to 2, we will swap it with this number. Numbers left index in other case we would swap it with none to index. After that we can increment it, and we know that at this index we're having 2. Should move it here, and we will have next index here. Maybe we can move this condition here. I will do it later. It should work anyway. So here we are. This is how we found, how we moved all the 2 numbers to the end. At the same time, we can do next thing. If here we have number 1, we will put it, if we have 0, we can put it to the beginning of the array, not just to this index. Or not. Okay, let's just keep it simple. No, let's think about it. We're moving through this array and we're swapping the numbers with 2. We swap either 1 or 0. We're moving from left index, and if we see that it is 0, we can swap it not with left index. So the position of 2 that we found, we can swap it with last position of 0. Sorry. Okay, the question is if we can swap all the numbers we need with just one iteration, or we should perform several iterations doing that. Okay, with every iteration, we're looking for 2 and swapping it with last index. At the same time, when we see 0, we can swap it with last 0 number, for example. And what will we do with left index in that case? At the same time, we can not only look for 2's here, we can also look for 0's. And if we see 0, okay, what I understood here thinking about it is that we can really do it. If we see 2 here, we can swap it with last non-2 index. If we see, for example, 0, we can swap it with last non-0 index. So let's try to do it. Non-0 index from start would be started from 0, and here we will make this thing. If at this index we're having 0, we will increment it. Then, what will we do with left index? Every iteration we can just how to say it? We can just say that left index would be equal to non-zero index from start, and start from this number. But at the same time, we can experience a big sequence of ones. What will we do in this case? Let's optimize it a little bit later. Let's start with I would say simple logic. Or not. I would say that left index should be math min between left index and non-zero index from start plus 1. Yep. So in this case, this condition is fair if we see that this index is equals to 2, then we will swap them and we will decrement and we will continue. If numbers at left index is 0, then we will swap it with non-zero index from start. And then we can just continue. And if there's nothing, then we can just increment it. We return nothing. So I believe it should work. Let me just check the logic and syntax. Here we have left index starting from 0. We can even use undefined here, or we can use minus infinity here, because it will be overwritten here, math, but it would be math max here. So every iteration we're looking for non-zero index from start and non-to index from the end. I would name it just from end. Well, then we count left index, and if left index less or equal to non-to index from end, then we will return yep. In other case, if number of at left index is 2, then we're swapping with 2. After that, index would be decremented. If we see 0, then we will swap it with non-zero index from start. After that, we will increment left index. Okay, what will I do? I'm thinking about this case when we have something like 0, 0, 0, 0, 1, 1, 2, 2. Well, no, it should be handled. Okay, I will try to run it and hope it will work, but let's see. I'm not 100% sure. Well, for some reason... I should sign in. Okay. Let's run it and see what do we have. Okay. Fair enough. Well, I see that something works, but for some reason we skipped this 2. So after every iteration, what to do? And here we skipped 2 as well. Let's log some numbers. None to index from end and numbers like here. Non-zero index from start 0, none to index from end 0, 1, 2, 3, 4, 5. Fair enough. After that, last index would be, well, left index would be 1. Numbers at index 1 is not equal to 2, and yeah, so we're starting from comparing this number with 2 or with 0, and this is a mistake. We should start from this number, and here if we see 2, we should swap it with this. Yep, so this plus 1 is wrong. Maybe the problem is in that. Well, yes, I see that first case is fixed. Now let's look at second case. Non-zero index from start 0, none to index from end 1. Let's log left index. Left index 0. So here we see 1, left index is 0, left number is 1. After that we're incrementing, left index is 1, and node to index from end is 1 as well. But here we see 0, and we should swap it with 1. So this condition is wrong, and we should swap last one here. Okay, now these two cases work. Let me try to submit it and to see what is happening, because I was thinking about something like problem with this condition before, and but I'm not sure that it will work in every case. But let's try to submit it. Maybe we will see some problems. No, we don't see any problems. The problem is solved, and I see that it is solved pretty optimally. Let's imagine how we can simplify this solution. Maybe we can do something with this condition, but I'm not sure. Let's look at other solutions in JavaScript, of course. Okay, we were looking at other solutions, and what do we have here? We want to sort the array containing only zeros, 1 and 2. The idea is to partition the array into 3 parts using 3 pointers: low, mid, and high approach. If it's 0, swap with low and move both forward. If it's 2, move high backward. Okay. If mid is 0, we're swapping it. If mid is 1, we're continuing. If mid is 2, then we're swapping and mid plus plus. So actually the solution is just the same as my one, but maybe a little bit more straightforward. Yep. So what we can do here, well, I don't think we need to do anything with my solution. It's pretty good. Pretty good. Yeah, okay, I think we can finish on that. Thank you very much.